Just getting set up here. Okay. Welcome to the stream, everybody. Today is August 22nd, 2019. My name is Nick Larson, and we are working on the JS13K games competition, the entry that I was hoping to make. Conceptually, this is like a little team fight tactics sort of a game. And where we've gotten so far, we spent the entire first week. We have 5 weeks to do this, 3 days apiece. The entire first week we spent making a CSV of all of the values that are going to end up being used, and we did this in a giant spreadsheet, which I can open up. And we also got a little bit of our idea done in the design notes here, which we'll take a look at as well. Here is, that only took me a little while to come up with. All right, here is all of the different units that are going to go into this game, all of the different stats. And the way that we did this is we basically said, for each class, these are your here's your base stats for all units. And then based on your class, you get a modifier, and based on your specialization, you get another modifier. And that is how and then we basically just said for each one of the units, you get your base attributes times your class and times your specialization. And then they all end up with unique values. Then we came up with names and abilities for all of them, which they'll do. And so yesterday, I started implementing the code to actually draw this board. And let's take a look at where we got in this. First off, the HTML is super simple. It's just including it. There's a canvas, some really minimal CSS, basically to make it so that it's full screen. And then, you know, the other stuff you need to have some valid HTML here. Now, the game itself starts off, and I'm just going to make this full screen and we'll go take a look at the actual game. So you basically just get a hold of the canvas, get a hold of the drawing context, set the game state, and then we come all the way down to the bottom and we say, all right, run the game. When you run the game, first it attempts to resize the canvas. It also makes it so that when the window gets resized, it resizes the canvas. So if we want to do something like, you know, resizing it, you can see that this little FPS meter down here, I don't know how easy it is to see that, but you can see that like it resizes the game area to match whatever we have going on. The only thing that doesn't resize is this up here at the top, and we might work on that at some point, but like right now, that's some complication that I am just not super concerned about, and I'm not going to worry about it. All right. So, what we want to do is keep looking. So after that, then we initialize the game state. This is where we actually pop in the players. The stats that we are recording so that we can show that little display on the bottom left-hand side. This will eventually get removed, I think. It's really just for like development purposes. And then we also have game state. This is all of the minions and all of the values were put into here. We gave them all random icons from from here actually, which I don't want to do because this is not in an incognito window. Let me close that. Let me go here. Let me go here. No. I'm just going to start closing this stuff, because it doesn't matter. Close that. I'm going to close that too. Okay. Oh, there it is. Alright, this is where I got all of the emojis from, and I just sort of like started copying them and pasting them. And we don't actually need that one. Okay, so there is our game board. And then we have all of, all of these things in here. And so wherever your pieces show up right now, I just randomly assign them to players. These are like your board, your reserves, and then you're actually going to place them on the board. So the goal today is to draw the board. This is a really simple, really short sort of a day. We're going to draw the game board, which is just going to be a grid. And then you get to place your people via drag and drop on your half of the board. And then what's going to happen is, that's basically all I want to accomplish today. I want to draw the whole board, and then I want to make it so that you can drag and drop your pieces onto your side of the board. And that's it. That's what I want to do. So hopefully it shouldn't be that hard. Of course, every time I say that, things end up being pretty hard. But we're going to work on it together, and we're going to get it done. All right. Also, yeah, like a lot of this is going to go away. So even though we're at like 2.4K already, I feel like, we're making a lot of progress. Oh, that's the other thing. There is one more interesting thing. I'm using a game loop here, which is basically just request animation frame, and it calls itself over and over and over. So in every step, we basically are going to update the game state, then we're going to draw the new game state, and then we're just going to request an animation frame. And that's how the whole thing's going to work, just over and over and over and over and over again. There's no way to get out of it. There's no way to stop it. The game will just switch however it's working. Okay. We'll worry about that tomorrow. Let's just draw the board. All right, so the goal now is to draw the board. We have update, we have draw game. So the first thing we want to do is draw the board. Render board. State. Okay. And we want to say const render board equals function of our state. And for the board, we're going to basically draw a giant rectangle. For now, we're just going to outline it in black. Okay, so I am literally looking all of this up as I go because I have never done any of this before. So JavaScript canvas stroke rectangle stroke rect. Can I get something? Here we go. Stroke rect. Okay. So we want to find the center of the board. We want to find the center of the board, which we're going to do like this. And then we're going to say the width equals, I don't know, something like 90%. No, the width, for now, we're just going to make it, something like 800 wide. That's my answer. And then what we're going to do is we're going to say so X is this way and Y is down. So we're going to say middle minus width divided by 2. And Yeah. Equals, I don't know. Let's just stick with 800. Width, height, and the top. Let's see. The top, we have this thing that's 100, 20, goes down to 145, and then it, so that's 170. We're going to put it at 250. And we want stroke style is black and stroke rect. And we're just going to see if that like did it or not. Ooh, all right. Okay, we kind of have a board here, but this is way too big, I feel like. We want it to be wider. So let's make it wider. Something like, let's just make it like 400 actually. And just see if that's better. Okay, we're gonna want it to be 1,000 and say 600. Oh, that's good. That's really good. Okay, that's a really good size board. Now we need to turn it into basically a grid is what we need. So how are we going to do a grid? Great question. I don't know the answer. A grid. How are we going to turn it into a grid? Basically, we're just going to draw a bunch of them. All right, we're going to have it be maybe cells of 100 by 100? No. I want it to be something like actually, yeah, sure. So canvas context. Basically, I just want to do this over and over. And I want to make the height of them height divided by num cells. Num vertical cells equals 6. Const num horizontal cells equals 10. Okay, so then we're going to say for let I equals 0, I less than num horizontal cells, num vertical cells, I plus plus. We're going to draw one of these, which is going to be height divided by 1.0 times height divided by num vertical cells. Yeah, I think that's right. And then that is always going to be the left, and then this is going to be plus offset, let offset equals I times this. Okay. Let's have something like const cell height equals this. I times cell height. We need this part to be fast. This is going to be running over and over and over and over again. And there might be a way to like render this image one time and then at the beginning, instead of like clearing the rectangle and rerunning all of this to draw it, we just like copy the whole image to the thing. Like maybe that's a way to do it. We can figure that out as time goes on. 250 plus offset. Okay, let's see how this goes. I guess let's see how this goes. I'm basically looking for a bunch of horizontal lines. Hey, that really worked. That worked really, really well. Although it seems too tall all of a sudden. Did it get taller when I did that? No, it didn't. Hey, what's up, Raz? How are you doing today? Alright, width divided by 2. And then we want to do the same thing for the verticals. For the horizontal. Num horizontal cells. Const. So there's this programming competition called JS13K. The whole concept is you have to build a game that runs in a browser, and all of the materials for your game, when zipped up, have to be 13 kilobytes or less. And there's been some really, really impressive stuff over the years. This is probably like the 8th year that they've been holding this competition. Just go take a look at it. Yeah, JS13K games.com, something like that. Anyway, yeah, I highly recommend going to check this out. Here's a link. Yeah, well, so pixel art, yeah, but it's also like the way that I'm going about it right now, I'm just scaling up emojis, right? Like when I show this, these are just emojis. So you get all of the graphics for free in 2 bytes because it's an emoji. And that's sort of the way that I'm like hacking it right now. I think ideally I would want to do something, but I want to spend more of my effort on like making the interactions flow like a game than about the graphics so much. I think, you know, just making sure that the game is fun to play is going to be the most important thing, and then after that, try to make it as pretty as possible. All right, concept. The concept right now is, all right, there is a theme in this competition, and the theme is the thing that changes every year. This year, the theme is back. Just the word back, B-A-C-K. And the idea is that, you know, you can interpret back however you want to. And so the first thing that came to mind was, wouldn't it be cool if, like, we had a game where you train a neural network using back propagation? And I was like, you know, you kind of have to like spend a lot of time doing it for real. So probably wouldn't be that fun of a game to like actually train one. And so I was like, can I come up with a concept where, right, exactly, not that fun of a game. So then I was like, okay, can we like use the concept of back propagation as like the key thing for a game, but then instead of actually training a neural network, instead you just go collect data and you throw it in there. right? And so the goal of the game is go collect data. Well, I threw, the more I talked with people about this idea, it was also like, it's still kind of dumb and not everybody's going to get it. Hey, that's cool that you're an amateur game dev. This is literally the second game I have ever created. The first one was on stream about 4 months ago, and I was doing a practice for this competition. So I have never done video games. This is totally new to me. If you have anything, okay, yeah, perfect. I am a web developer. I was a web developer for 5 years or so, and then well, maybe 6 years, and then I switched over to doing data engineering, which is what I do now. Um, but at this very moment, I am an amateur game dev as well. So conceptually, I was like, I still don't like this, and then I was like, this game that I'm playing all the time right now is Teamfight Tactics. So then I was like, what if we did something like Teamfight Tactics, but your brain controls the units, right? Because in Teamfight Tactics, you're more like a game manager. You don't actually like control the individual units. You just choose the ones you want on your team. You choose where to put them on the board. And then when the game starts, the characters just do whatever the hell they're going to do on their own. You don't control them. You just watch it at that point. And so I like that concept from like a very simple, small, easy to implement sort of a game. And that's the direction I ended up going. And although these are, although this is a monkey and a pig right now, these are going to switch to be brains, like images of your brain. And the way that we're going to do that is that you're still going to be training your brain, and we have split it into the left side of your brain. Yeah, auto battler, exactly. So we split it into the left side of your brain and the right side of your brain. And each side of the brain can control certain kinds of units. So you cannot have your left brain control more than two units at a time, and your right brain can control 2 units at a time. And because of that, it allows us to figure out, to come up with interesting combinations of the units. So we went through, we said, all right, here's all the design notes, and we were like, let's take a look at these, right? The left brain is the analytical side, and these are the sorts of things that it's going to be responsible for. The right brain is going to be responsible for these other things. And then we came up with all of these units and all of the different things that you have. We came up with names for all of them, came up with ideas about what of the individual specializations will matter. And then we got done with all of that, and we came up and we were like, all right, now we got to come up with actual attributes for all of these things. So we basically said all units get these base attributes like this, and then based on your class and your specialization, you get multipliers. And so for any individual unit, how does this apply to back? All right, so the back prop thing, the brain thing, how your brain controls all of these things is going to be largely based on whether you train your left side of your brain or you train the right side of your brain. So as you're going during a match, you get to choose which side is learning, right? That's what back propagation does. It's the learning part of the brain. And so you get to choose which side is getting better during like any given fight. And then as you level up one side, those units get stronger. And right, so there is a little bit. It's not actually like training a neural network or anything like that. It's just like, a counter basically. And once your counter gets high enough, your brain levels up and your units get a little stronger on that side of your brain. So if you want to focus on one side or if you want to focus on the other side, whatever. And that's where it comes from. And then also sort of the like specialty attacks and whatnot are all as much as possible going to relate to back. Like you can backstab, or you can like knock back, or whatever else like that. So it's really just a very loose interpretation, with the main concept being that you're training your brain to be better at one side than the other. And then it's just a tower defense game. Your brain has life. That's what these green bars are. They turn red as your life goes down. If your life goes to 0, you lose the game. Does it affect how your opponent learns? I haven't really gotten that far, to be honest with you. So I think at the moment I want to leave it so that you can't really screw with the other person's brain. Yeah. like because this is a time limited thing. I think it's pretty important to like scope this down as much as possible and think of this more as like a prototype than like a fully fleshed out and amazing game. And this is just like, all right, you know, the more we do this, the better off we can kind of get here. You know, I want to get through some set features, make sure that the game is like playable. There is a win condition, you know, there's a starting condition, all of that sorts of things, and then just get through the game. And then after that, you know, spend as much time as we have at the end sort of grinding through making it as like playable and pretty and whatever else. But yeah. So what I'm doing right now is I'm turning this into a grid. And then I am going, once I'm done turning this into a grid, I'm going to implement drag and drop so that you can actually take your units and like move them onto the board. And that's what I'm hoping to accomplish today. Why wouldn't you just go with ham on one side? Oh, you mean the name? I don't know. No? HAM? I'm lost, man. I'm sorry. Oh. That's funny. It's not a bad idea. All right. So let's get this done. Why choose one over the other? Why choose one what over the other? Oh, you know, it's not really either. Like the human player is always going to be on the left, and the computer player is always going to be on the right. Oh yeah, why choose one over the other? Great. Okay, no, that actually does make sense. So your units are like they have different things that they're good at, right? So these units are good at logic. These are good at planning. These are good at math, right? So like as you level up the left side of your brain, these sorts of attributes get stronger. And then as you level up these sorts of attributes, these sides get better. You'll notice that there's epics and rares. Like you're not going to end up getting all the epics. So you probably want to train the side of your brain to make your epics and your rares stronger, because they'll get more of a benefit than training the side where you just have a bunch of commons. In terms of like the rarity of the units. So you get a boost for being, you get like a skill boost of 1, 2, and I'll probably even bump this up quite a bit. This will probably end up being like a 1.25 and like a 1.7 or something like that. So you get a real huge boost for being epic, and then every time you level up your brain, it will additionally be another boost on top of that. So you know, numbers that multiply, big numbers that multiply versus bigger numbers get even bigger than smaller numbers. So you're going to want to level up the side that you have the best units on. And maybe something more interesting when we get there, but right now that's all I'm... So yes and no. So like you have to start leveling your brain from the very beginning. Right? And your brain will level up like proportional to the amount of damage that you've done. So if you do a lot of damage, you might level up one side faster than your opponent levels it up. And in that case, you know, you have to start leveling your brain from the very beginning. You can't wait until you get an epic and then choose which side to level. So it's sort of like is a telling tale to your opponent, like what sorts of things they're going for. So in between each of the rounds, just like in Teamfight Tactics, there will be a round where you get to choose, you know, an additional unit. Whoever loses the last round, or maybe it's whoever has the less life, is going to get to choose first, and then the other person is just going to be forced to take whatever the other thing is, if they want it at all. And so you know, there is an advantage to having less life. There is you know, an advantage to seeing what your opponent is doing, because you'll get to take a thing or leave them with, you know, this other thing. And then the way it works out is the units come in pairs. So there are 2 of each class, and there are 6 of each specialization. No, 4 of each class, and 6 of each specialization. So there's 24 total units. And because your left brain can control certain classes, you cannot have more than 2 of the same class at the same time. So there's some like skill around determining, you know, which direction you want to pick in all of this. And then the rarity of the units makes it so that you would absolutely, like the way that we assigned the rarity makes it so you would not want to choose the same thing that your opponent chooses. Something that auto ballers do, battlers do, is the ability to sell and buy, which allows you to change up your strategy mid-game. Yeah, absolutely. So it's the same idea, only because there's no like merging of units, there are literally 1 of every unit in the game, just period. And then you get to choose after the round, you know, a box will pop up. Whoever lost gets to choose 1 of the 2 units, and then the other person can choose, do they want that unit to swap out for one of the ones that they have if all of their spaces are full, or do they want to just stick with what they've already got? And because of the way that there's like, you know, a limit of 7 total units that you'll be able to have out of 24, there will be enough opportunity to switch out and grab whatever it is that you want mid-game. So both sides should be able to come up with good boards as the game goes on. That's the hope anyway. I don't know anything about balance. I am an amateur. I don't know. I haven't played this game at all because it's not even prototyped here, and that's what we're trying to get to. This seems like if you don't choose the right side at the beginning, you won't be able to change up and start mid-game. Well, that's the thing. Even if you level up the left side, you know, and all of your things, and your opponent gets the epics for the left side, they can only play 2, so there's not a lot of reason for them to hold on to the 3 rares that are on that side. And even if you get, you know, the 2 rares, then you should still be able to like have some sort of improvement here. And it's also set up so that you wouldn't really want to take the epics because they don't share. They do not share. There's only 1 epic for each of the specializations. So if you grabbed your, you know, 2, if you grab 2 epics, you cannot make, or if you grabbed all 4 of the epics, you would miss out on the bonuses, the specialization bonuses. So you wouldn't want to do that, is sort of what it comes down to. No, that's awesome. I like talking through this stuff too. I mean, I'm at the point of the game now, just because it's time limited, where like we have to start getting, you know, features implemented so that we can like prototype playing around with it, and then we can worry about balance a little bit later. And I honestly, like, I have no idea how long it's going to take to get it to this point. Today, my goal is draw the grid here, which we're almost done with, and then implement the drag and drop. And then after that, I think we're going to get into the actual game part of it, where you put your things on there, and then the game just sort of starts when it's ready to start, and that's that. And that's what we're going to do. You know, and then we'll be able to start looking at balance pretty early on. But let's go ahead and get this grid drawn and see just how far we can get today with the drag and drop. So width equals 1.0 times width divided by num horizontal cells. Okay, cell width. Middle. Okay, this is going to be 250. The offset. Okay. Plus offset. We want this to be cell width, and we want this to be just height. I think that's going to do it, but I'm not 100% here. All right, we have our grid set up. That's perfect. And now we need to do the drag and drop. And for this, I found this really useful thing earlier today, right before I got on here, that implements drag and drop, where you can literally just pick things up and start dragging them. And so basically this is what we're going to try and do. And the only trick of it is we're going to make it so that as you're dragging them around, they latch into certain cells, and it's limited to only allow you to latch into whatever cell you're closest to. That's the goal. And then maybe we'll color the cells so that it's obvious. Actually, that's not a bad idea. We should go ahead and color the cells so that it's obvious which side you're allowed to put things on and which side you're not. Okay, so we want to fill a rectangle. And before we do this, we want to say canvas.fillStyle. Fill style equals, I don't know, no, I'm not using a game library because it's limited to 13 kilobytes. I'm trying to basically implement this as much by hand as possible, because pulling in any dependencies, you'd have to spend time going through and ripping out all the crap that you're not going to use to make sure that you can compress it down. Yeah. Well, I went with the simplest possible thing for a game loop, which was game loop, update the game state, draw the game state, request the next frame. So I don't know if this is gonna work or not, but that's just the direction I'm taking it right now. All right, let's take a look. I want fill rect. Fill rect, offset there, width and height. We're gonna make the dark gray, and then let's go with CSS grays. Color shades. Dark gray. And I don't know, just gray then. Okay, that's fine. So we're going to fill the whole thing, and then we're going to do it halfway with just gray, because the background is light gray. So we want width divided by 2. I guess the biggest part of most engines is the graphics, which you already get with JS. Yeah, more or less. I think one thing that I'm struggling with right now is when to worry about the locations. Right now I'm placing everything raw relationally to the screen, and that's not going to work. Some things need to be relational to other things, and so I need to get that sorted out before too long. For instance, if a character is moving, I want to make sure that whatever the things are that get drawn around them are moving with them, stuff like that. That sort of a thing. I want to make sure, yeah, I don't know. We'll see. We'll see if it turns out to be a problem or not. Gain, yeah, exactly. Exactly. When it comes to the AI of these things fighting each other, it needs to sort of get to the point where, you know, the movement, it knows to move closer to the other thing, but it needs to be like within the bounds of the board and not leave the bounds of the board as much as possible. Okay, let's see if this worked. That did not work. Did I save it? I did save it. Fill rect. Okay. Width and height. Fill style. Did it crap out on me? No? That's frustrating. I almost wish it had. What if we just change it to different colors, like red and blue? Or maybe stroke rect? Is it overwriting it? Let's see here. Let's put this at 200 and let's put it at 300. Let's put it at 350 and see if that is what's causing the problem. What? It's like not updating at all. Oh. You know why? It's because I don't... No, I do have that set up. Are they rendering behind? Yeah, that's what I was thinking. That's what I was hoping, but it just seems like it's not updating at all right now. Like I just changed the location of it. Oh, you know what? No, okay. I need to change the location of both. I need to change these as well. All right, this is a situation where like I just changed the location and now all of them need to. Let's just make this top equals 350. I want those to explicitly be that top. 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 Fill rect. What if I just cancel all of this? Like, why is that not drawing, right? Oh, that's interesting. Fill style. Do I have that? Fill style. Fill rect. Fill rect. That's super frustrating. Not entirely sure why these aren't drawing. Where are you calling the render board? Right here in draw game, which gets called right after the board gets reset to gray. So the board gets reset to gray. Did I spell these wrong or something? Fill style. Nope. Oh, I put it on canvas. Canvas context. Okay. Let's see if that works. Hey, there we go. Okay. Now I want gray and dark gray. And then I want to put this at top. Top. And put the top back to 250. Okay. Hey, all right, there we go. This dark gray. That's super interesting. I would have expected that. Hey, Code Rush. Thank you for the raid, man. I really appreciate it. I hope you had a good stream today. What were y'all working on? We are working on a game right now. And I'm learning all of this as I go here. Why is the right side dark? They start at the same top left. Maybe I just misread the colors. CSS grays. Oh, I guess gray is darker than dark gray. That is the dumbest thing I've ever seen in my life. That's why it has these exclamation points. That is so silly. Why would they do that? Who came up with that? Whatever. I'm not going to worry about it. It's not super important. It is super important. I want to be able to say you play on the darkest squares. Sure. All right, let's put the rest of the lines back. And let's see if the board is done. Hey, all right. All right. All right. Okay, we got a board. You get to play anywhere on the dark squares. All right. Now we need drag and drop. Drag and drop. Let's go take a look at this. All right. You need yourself a canvas. All right, we got one of those. Good. You need yourself a shape. Well, we've got those. They're called minions. Here they are. Minions. These are going to be our shapes. Why are they going to be our shapes? Because they're game objects. Okay, great. What else do we need? Locations? Oh, this is important, I suppose. Shape. Okay. Location, XY. This dot size equals height 1, width 1. Okay. And then, so now these things have these, but we actually want to make them more like 100 and 100. No, we want to make them, what, 50 by 50? Something like that. Probably want to move the size of them. Yeah, probably want to move the size of them into here. So that when we draw it, we're not... Okay. Render player pieces, I suppose, something like that. I am specifying these in here. Those are the avatars. These are the minions that are in reserve. So maybe this is part of the player. And then what I want to do is say this should come from the actual game itself, from the actual minion. What is it that I'm trying to do? I need a box for each one of these. That's what I need. Okay, so let's look at this. I need a box for each one of these. Okay. And then keeping track of the canvas state. Hey, what's up, Codebase Alpha? How are you doing today, man? Okay, let's just pretend there is a box. We're going to set the side. Things are good. At work we've been having this like real crap show of like trying to build out a new model for our ad server. Like we spent all this time coming up with we had a model, we spent all this time like doing the work to implement it, and then once we got it all implemented, we put the test out there and it was like 20% regression in click-through rate, and we were just like, what on earth? Like, why is this happening? This should not be happening. And we kept going and kept going and kept going, and it was like every single thing that we tried, every single modification that we made to it was just crap, crap, crap. And so eventually we were like, we just have to keep the pipeline full of like tests, so that we're not wasting any time. And so we started doing the most naive stuff possible. One of which was just run the exact same model that we have in production today, only throw out half the features, and poof, it's like 10% improvement in click-through rate. And it's like, it solves the business problem that we were trying to solve, which is the features that got thrown out were problematic. I mean, obviously, but they were problematic for other reasons. And they needed to go, and that was like the whole point of doing all of this new model training, was to get rid of those. And it's like, for months, literal months, we were trying thing after thing after thing, and it just kept failing, and it was like mentally draining on me, like at this point. And then you just try something super naive, and all of a sudden it's just like poof, it works. And so things are good in that sense. In the sense of like finally seeing some success, but it's also like gotta try and understand why it made the improvement as well now. But yeah, things are good. Things are good at work. Things are good at home. My kids are in school again, so like it's quiet around here during the day. I got myself a beer making kit, which I'm super excited to try out. I mean, I got things going. But yeah, thanks for asking. How are things with you? Keep it simple. Things are not so great at work. Very frustrated. I know that feeling. I hope it's not like... I hope it's a technical problem and not like personal problems, emotional problems, management problems. Those are much harder to deal with. Let's see here. All right, so we have our board. We're just going to pretend that we have a shape that has these four characteristics correctly set. I'm just going to hack it. I'm just going to put them in there exactly what it should be. Okay. This dot size dot height equals 50. This dot size dot width equals 50. Okay, great. Did it. Ooh, the location. Ooh. Look. That needs to be updated. Third-party communication problems. Yeah, that sucks. Sorry to hear that, man. Maybe we have screen location. Okay, so I just need to know where on the screen this thing is. That's what it comes down to. I need to know where on the screen this thing is. I'm not entirely sure how to do that. Let's say we go with, when we update the state, we want to, as a very last step, okay, update positions, update screen locations, const update screen locations equals function of state, and then how do I want to do this? I want to say something like no, this really needs to be part of the rendering. I'm not entirely sure how to do this. At the point at which I am, okay, let's just, I'm gonna have this be this dot screen location equals x0 y0, and then at the time, right, this is me drawing. This is me drawing everything, but I'm like telling it where on the screen to draw. And instead, what I should be doing is directly loading this from the object that I'm trying to draw. That makes sense to me. That makes sense to me. Okay. That's what I'm gonna do. This is gonna take a hot minute. Class, scene extends game object, constructor. This is going to be super. I don't even want this name to be, this is going to be game scene. This is going to be the game board scene. Oh, whoops. Name. Then it's going to get a bunch of components. And then I'm going to have this thing be update screen locations. And the way this is going to work is it is going to be current, okay, relative location. And then we're going to be this dot screen location dot x equals this dot location dot x plus relative location dot x. So the concept here is at the beginning of the game loop, I'm going to loop through all of the objects and I'm going to update their screen locations. Or I'm probably going to update their actual locations first, and then I will update their screen locations. I think that's correct. And then we want to say we want to say this dot components dot for each component for each component. We want to say c dot update screen locations of this dot screen locations. Okay, I think conceptually this is going to do what I want it to do. And now we just need to make everything actually work. Okay, so now we're going to have something like a pre-render function that like looks at the screen size and all of that. I'm just going to make these 100 for no good reason other than to do it. Okay. So now what we need to do is construct game objects. I don't even need this. This is literally a pass-through. I don't need this at all. Okay, so now what we're going to do is we're going to say that when we are constructing the game state, we're going to say game state dot scene equals new game object of game scene. Okay. Now we're going to add in an object to the scene that represents halfway across the scene, because I want everything in this game to be halfway across the scene. How are we going to do that? How are we going to do that? Game object. Okay, let's screen location. All right, we have a game object. Now we need a game object that is halfway across. And the way that we're going to do that is we're basically going to say set location. Okay, all right, I think I got this. So we need a game object that we can modify. We need a game object that can fill up the whole screen to draw the background, and that's going to be the scene. Okay, let's do that. Somehow I need this scene to have height and width equal to the height and width of the screen. So let's do something like if GameState.scene and we'll just rotate these. All right, if GameState.scene, which I can now guarantee is going to be there, then we can say GameState.scene.size.width equals win.inner width, and the same for this. Inner height. Okay. GameState.scene.width. Great. Inner height. Oh, gotta make that the height. Okay. Then that takes care of that. Now let's put a renderer. Let's do something like this dot renderer equals null. And let's do something like render. And we want to say if this dot render, then this dot render dot render. And then the same thing right here. For each component, we want render. Okay. And then I think what happens conceptually here is update is going to update the stats. Then we're going to say state.scene okay, do the game logic. State.scene dot update screen locations of x0, y0. Okay. So that will update the screen locations, or maybe that's part of the draw step. I think that's going to be part of the draw step. Okay, so in the draw step, I don't even want this anymore. But we'll figure that out in a second. And then I want something like that scene dot render. Alright, and the reason I don't need this anymore is because this is going to become a renderer. Class rect renderer. And this is just going to have a constructor. Okay, this is going to be x, y. No, this is going to be height and width. This dot screen location. Okay. This dot height equals height. This dot width equals width. And then we want this render function, which takes in a location, screen location. Oh no. What did I do? And then I want to say, oh, and I guess we should do color equals black, fill equals true. And then we want this dot color equals color, this dot fill equals true. And then here we want, okay, canvas context dot, okay, if this dot fill canvas context dot fill style equals, let's call this fill style, equals this dot fill, oh no, fill style, let's call it style. I know I'm changing the name a lot. It's because there's stroke style and fill style. Okay. And then I want canvas context dot draw, nope, dot fill rect of screen location dot x, screen location dot y, this dot width, this dot height. Else stroke style and stroke rect. Okay, rect renderer. Great, now we have a rect renderer. Okay. So now I need to give the game scene game state dot scene dot renderer equals new rect render height. I don't need this. I just need these. Size. Okay. Okay. Rect renderer. Okay. Equals new rect render. The style is light gray. Fill is true. Equals true? Okay. That will give me the gray screen. Allegedly. Which is kind of cool. I have these players. So I need to basically add the player views. Okay, so we're gonna have to just do this. All right, so we have GameState.player, and we have GameState.stats. Let's not worry about the players for a moment. Let's worry about getting the stats in there. Okay. We have class text renderer. Same concept. I think we want the font, align, baseline, fill style, and okay. Let's just copy all these. All right, that's our rect renderer. Our text renderer needs to be able to do this crap. Okay. Text. No. We need font equals maybe let's do 20px Arial. Style. Okay. Align equals top. Equals left. Baseline. Baseline equals top. Okay. So now we want all this stuff to come down here. We want this dot font equals. Is there a way in JavaScript to like make it so that all of these args become properties of my object? Because that would save me an enormous amount of frustration. JavaScript function args to properties. There is args. Okay, arguments. How can I get the argument names? Function.arguments. Named arguments. Notice the curly braces. We are receiving an object now. Nah, I'm just gonna leave it like this for now. If we need to hack this later, we'll figure it out. Okay, this dot font equals font. This dot text align equals text align. This dot text baseline equals text baseline. This dot style equals style. This dot fill equals fill. Okay, canvas context dot text align equals this dot text align. This dot text baseline. This dot fill style. Nope, I don't actually want that. This dot font. I want fill text. 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 let's say this makes sense to me, but I pass in the screen location. Let's do okay. Game object. Let's just have it be the game object itself. This. And then we say game object okay, let's try that. And then for the game object here, same concept. We're going to have... No, we're not doing this. And we're just going to assume that this game object has a property called text. Yep. That's what we're going to do. Stroke text. Okay, I feel like we're kind of like doing a lot here without testing, and we probably ought to test. So I'm going to get to the point where this will draw where it will draw the thing, the whole background as light gray, and this little stuff down here that is tracking the frame count. That's what I'm going to do. Just to make sure that everything that we've done is working so far, and then we'll like figure out how to get the rest of this into this sort of a format and just sort of see where we are. So we have a text renderer. It is assuming that the thing has something on there. So now we need a text object. That's what we need. Game object. We need a class text game object. Extends game object. Constructor. Name. Super name this dot text equals name. Text equals null, something like that. Okay, and then we want something like this dot text equals text. Okay. So we have a text game object. Now what we want to do is figure out how to make it draw these things. Okay. Let's go down to here. We want to make it draw the game stats. So they're going to need a game stats object. Oh man, have I gotten in too deep here? Probably. Okay. I don't need this player. I'm just going to start commenting a bunch of stuff out. All the stuff that I don't need to make it a little bit easier for me to keep straight in my head. I don't need minions. I need this resize canvas thing. Okay. I don't need any of this. I don't need these. Alright, so we have run game, which initializes the game state, resizes the canvas. Probably want to set this up to actually be in here, because I don't want it to accidentally resize before it gets there. Okay. Initialize the game state happens right here. We create the actual scene. We render light gray. In fact, that's all I need to do. I'm just going to be totally clear. That's all I need to do. I want to see a gray screen, not a white screen. That is my plan. All right, initialize, resize the canvas, add in our event listener, run the main game loop. The main game loop says update. It tries to update stats, which we're not going to do right now. Okay. Then it says draw. Draw says state.scene.render. We don't need this draw game. We don't need render board or render players. That cuts out a lot. We also don't need this. Okay. So, and I don't need this draw stats. State.scene.render. So what's going to happen is it's going to go to the scene, boom, on this game object, and it's going to call render. Render says, if there is a renderer, then render this. There is a renderer because we set it. Renderer is, in this case, a rect renderer. This text renderer can go too. All right. I think that's the minimal amount we can do here. We just want to see that when we run this, what we end up with is a giant gray screen. That's it. I just want a gray screen and no errors. That's a white screen. That's not good. What is happening? Refresh. Is it? Let's make it green. You know what? Let's make it green. Let's not make it light gray. Let's make it something that would obviously stand out. Okay, that is not working. So let's figure out why. We initialize the game state. We have a game object. We have a renderer. We are setting the renderer to be a rect renderer. We're saying we want it to be green. And we want it to fill. Rect renderer. Style is green, fill is true, style. Oh, that's an accident. Whoops. Okay. Fill style, fill rect. We pass in the game object. We are passing in the game object because we're passing in this. So let's do a console.log this. Oh. You know what we're doing? We're setting the size to 1. So I think let's try this and just see what it comes out as. Refresh. Now stop. I really want to... How do I kill the JavaScript? That's not what I want. I want to stop the JavaScript. Pause. This is frustrating because I can't open. Hey, I can. All right, there we go. Okay, we have a renderer. Oh, renderer. Render. There we go. Let's see if that... Hey, all right, there's... Okay. Spelling mistake. Okay, so what we have now is a rect renderer that we can render for the whole screen. That does that. Now let's get the text in there. How are we going to get the text? First thing that we have to do is update the screen locations, which I believe we did in here. State.scene update screen locations. X0 Y0. Then we want to render. Okay. Okay. Now we want to compose up the stats. Really what we want to do is just draw text on the screen. So let's just focus on that first. So now we're going to say let context equals, okay, context dot we want basically a game object to represent where this thing is. Not even gonna have this here. We're just going to say let const stats box equals new game object stats, new game object, basically. And okay, stats box. Then we have stats box dot components dot push, and we want a new text object, game state dot new text. What did I call it? Oh, I deleted it. Text object. Okay, text game object. And then we want this dot render equals new text render, which I also have to undo. Which I think I also want to put all of this in here. In here. Equals new text render of font, text align, text baseline, style fill. Okay. And that's going to be our text renderer. Okay, is this any better? Is this any better defined in TypeScript over JavaScript? You know, probably. I decided not to go with TypeScript for two reasons. One, I would be learning TypeScript as we go, and this is like a time-limited exercise here. And then the second thing is I'm pretty sure that it adds in a lot of I, I I feel like TypeScript is typically more code when like fully rendered than like you can do with vanilla JavaScript, but I might be wrong about that. I don't really know the answer, to be honest with you. So that's our text game object, and it gets a text renderer by default. So let's go ahead and just do that. So what we want to do is we want to say stats box gets a new text game object of FPS text, and the text is just going to be null, and the font equals 10px Arial. And the rest of those we're going to leave alone. Maybe the fill. No, the style equals black. And then we... Oh, that's not even going to work like that. Wow. Okay. So now we're going to say stats box dot location dot x equals 20, meaning we want it 20 away from the left. And then stats box dot location dot y equals game state dot scene game state dot scene I need to basically anchor it to the bottom. Nope, I'm just going to put it at 2020. Stats box dot size dot width equals, I don't know, 150. Stats box dot size dot height equals 1025 35. Okay, now we have the FPS. Let FPS text equals this, and then we're going to say FPS text dot location equals 5 dot x FPS text dot location dot y equals 5. So basically putting a padding of 5 here, and then saying FPS text. I guess we're just going to put the name. Okay. FPS. I think I actually wanted this one. Monospace. 0.00. Okay. FPS dot. I think that's going to be it. Then we have statsbox.component is going to be FPS text. And then we basically want this again. Instead of FPS, it's frame counter text. Frame 0. And then this one, still 5. This time I want 20. And this is frame counter text. Okay, that's kind of a lot to get a stats box. Now we need to add the stats box. Game state dot scene dot components dot push stats box. Okay. Hi, Nick. Starting Monday, I have to make sure to go to every single class. Also, football is so close. I learned about stacks, queues, and hashes last night. That's awesome. Yeah, definitely get to class. Also, good to see you. Alright, let's see what's going on here. Poof. Hey, what's up? I actually put the stuff on there. I need to stop. Okay, I need to stop this from printing this out. This console log is not useful. Okay, so we actually have the things on there, but we'll notice a few things. First is that they are not lining up, which is a little weird. And second, they seem to be relative to each other, which is also a little weird. Right? I should call this just initialize. Okay. Stats box. What am I looking for? This one. You know what? Let's put a renderer on this. Let's do statsbox dot renderer equals new rect renderer crap all. I'm gonna go ahead and fix that. Rect renderer. Okay. And we're gonna make it green. We're gonna make this one light gray. This be style equals, I don't know. Just gray, I suppose. No, dark gray, as we figured out was a good idea. And fill. I think fill true is the default. Okay, fill true is the default. So we're going to get rid of this fill true. Okay. And let's see how that ends up. Okay, so I believe this one is going into the right place and this one is not. Alright, these locations are good. FPS. Oh, it's right here. Okay. Hey, alright. Okay. We can make this like 100. Alright. That's cool. Now let's make it actually update like it was doing previously. So this stats box needs to basically all right. This is kind of crappy. It's very verbose. Like, I don't know if there's going to be a better way to go about that, but we'll figure it out. Okay. Now what we want to do, we have it doing those. We need to actually update the game stats. Okay, so update game stats. Do we just go with this? Give me just one moment. I'll be right back. All right, and we're back. Okay. Yeah, sorry about that. I had to let my dog out. Okay, so we have it drawing these. Now we need it to actually update these things. I think I want it to update them by having GameState.stats be basically exactly the same as it was. And I probably want to set this up even higher up. Like this. Okay. Then I want to update the game stats. In exactly the same way. Okay. And now I just need some way to force it to... So I'm never going to need this anymore. These just become part of the game and you just remove them when you don't want them there. Okay. Okay. Let's get rid of all the stuff we don't care about. Render. Render. Update screen location. I think I probably want to not have this be recursive and call it inside the render loop. Right? Like just have this be, let's just do it like this. Location. And then we just right here, when we render this, say this dot update screen location. And then we don't need this here anymore. Right? State.scene.render. Now we don't actually even need this render anymore. You can just remove this. Be game state.scene.render. Request animation loop. Okay. And the thing that's important is this needs to be oh no, I need the screen location from the parent. Ah, damn. Yep. Okay. Okay. That's fine. It is what it is. Okay. Update stats. All right, this updates the stats, but it also needs to update let's just have this be update. Right? That's how your game object works. And then if you want to override it, I don't know how to do that. JavaScript. JavaScript. Oh, wait. No. Okay. Okay, let's say something like class game stats. I would like to be able to just have a thing that I add to it that's like, do these things. I don't know, maybe that is it. How about this dot updates? And then we have this thing called update, which is for each. Okay, this dot updates. And we're like, update goes to update. So you put functions in there and then it just runs them. And then you say this dot components dot for each dot update. Let's go to task. Okay, so then for each object you just put a bunch of updates in there, and at the beginning of the loop we're going to call this, and it's going to run that code, passing in this as the context. And then it's going to run the update for all of its children, for the whole tree. I guess. I guess. How would that work? We're going to, in the update function, call GameState.scene.update. Okay, and that would do all of the updates. And it almost feels like update stats could just be part of the scene. But then the stats wouldn't actually be on the game state, they would be on the scene. Okay. I feel like we're just going to leave it like this for now. Can't think that it would be better the other way. Okay, so we have game state update. And now what we need to do is make it that when this thing gets updated, stats box dot updates dot push, and what we want is game object. I'm just gonna put gobj gobj dot renderer dot gobj dot text. Oh, I don't want it here. I want it down here. Statsbox.updates.push. I want FPS text dot set text FPS colon plus game state dot stats dot frame rate dot to precision 4. And this one should be frame counter text dot set text frame dot stats dot frame counter. I think. Oh, look at that. The frame rate is bouncing all over the place. But it's working and it's updating. Okay, so I think I kind of like this pattern for doing it a little bit more. I now need to make it so that I can put things wherever I want, and it should also handle resizing pretty easily. Like I want to be able to say like, oh, I want this to be on the right hand side, and it should be able to do that. That's really unstable. It seemed much more stable earlier, like when I was testing it last night. Who knows? You know, the other way that we do this is we just pop more of these in there. Like that. And then we try it again. Still wildly unstable. I don't know. Okay. So the crazy thing is we rewrote the entire rendering engine. But now everything is basically going to be defined here in the initialize function, which is going to build out the scene, which is going to have all of the pieces. Which is great. Which means that things like draw stats, that is actually gone. We don't need that anymore. You know, this is a whole lot less code. This is my only problem. This right here is so much less code than this. And that is a little frustrating. I wonder if there is a better way to do that. Not super sure. You know, we might be able to like add, I feel like this sort of stuff is going to happen quite a bit. So we might be able to add it to here or something. I don't really know. I just don't really know. Yeah, I don't really know. Okay. Well, in any case, I feel like this is a better way to go about it, because now if I want to know where something is, I actually have my screen location and my size. So that puts us a whole lot closer to being able to actually do the drag and drop, which was the goal for today, but we're just not going to be able to get to it. So it'll have to be tomorrow. Or maybe I'll do it tonight if I get bored. And yeah, that's kind of that. So we rewrote the entire rendering engine. Now the only problem is, you know, we have these renderers that are specific to each one. Wonder if that's going to end up being too much work. I don't know. Okay, today was great. Let's see. Okay, yeah, I think we're just going to put a stamp in it here, and this is going to be it for today because I've got a call in about 9 minutes that I got to get to. But thank you, everybody, for stopping by and hanging out. I really appreciate the raid from Code Rushed, and everybody who chatted. Thanks for hanging out as well. I will be back tomorrow. I think I'm going to do this for a kind of large portion of tomorrow. Maybe starting around 10 a.m. East Coast time, and then just sort of working on it until the end of the day. So hopefully we will see everybody tomorrow, and if not, I hope y'all have a great weekend. Thanks for joining, and y'all have a good one.